Hi and Assalamualaikum. We'd like to continue our journey in reactor design class by explaining to all of you about bubble column reactor. So, what is bubble column reactor? Okay, so first of all, I will explain to you the concept of bubble column. The bubble column reactor is applying the concept of dispersion of gas in a continuous liquid phase. Bubble columns are a type of sparge tank. In a sparge tank, the gas stream is introduced in the form of small bubbles. Bubble column is commonly used in purifying nitroglycerin with water. Other than that, it can be used for radioactive elements because there are no moving parts in bubble column reactor. Okay, in the chemical industry, it is used for hydrogenation, oxidation, chlorination, and alkylation process. Alkylation process is very familiar in the manufacture of synthetic fuels by gas conversion. So for the biotechnology field, bubble column is useful in single cell protein production, animal cell culture, and antibiotic fermentation. So next, I will show you the example of bubble column reactor used in industry. The first picture shows us how the bubble column process occur in bioprocess technology, and the second picture show the water treatment process in order to get clean water. So now let's move on to the specification of bubble column. Okay, this is the bubble column used in industry. So the vessel used for bubble column is usually cylindrical with aspect of height and diameter. The use of large diameter reactors is desired because large gas throughputs are involved. Okay, large reactor height are required to obtain large conversion levels. That's why the bubble column used in industry is large in height as they want to generate product in a large scale. So next one is the flow rate of air or gas influence the performance factors. Gas flow into column is measured via rotameter. Air or gas is introduced at the base of the column through gas distributor. There are three types of gas distributor, which is metal microporous sparges, perforated pipes or plates, and the third one is the ring type. There is a electric heater installed in the bubble column in order to maintain constant temperature in the column. Okay, as shown in the animation, gas enters at the bottom through a gas distributor or sparger, shown by the movement of arrow from orange to yellow, and is dispersed in the form of bubbles through the liquid stream, shown by the movement of arrow from blue to violet. Okay, the bubbles rise at a velocity determined by the bubble size. The larger the bubbles, the faster they rise. Spargers are designed to produce consistent bubble size so that all the bubbles rise at the same velocity. Next, I will show you the flow system in bubble columns. Okay, the flow in the bubble columns is divided into three types, which is homogeneous bubble flow, heterogeneous flow, and the slug flow. Okay, the three types of flow is influenced by many factors. So, the first factor is the gas velocity. Okay, gas velocity can affect the size of bubble produced in the column. Okay, for the first one is the homogeneous bubble flow can be obtained at low gas velocity, which is approximate low than 5 cm per second. Bubble forms is relatively in uniform small size. The second type of flow system in bubble column is heterogeneous flow. So, heterogeneous flow is maintained at high gas velocity, which is higher than 5 cm per second. Okay, unsteady flow patterns and different size of bubbles are formed due to high gas throughputs. This type of flow can be observed in industrial size, large diameter column. The last one is the slug flow. Okay, this flow can be observed in small diameter columns which is higher than 50 centimeter. This type of reactor usually used in lab. Okay, the bubble produced is large as the flow rates of gas is higher. Next, I will show to all of you the type of bubble columns commonly used in industry. The first one is the cascade bubble column, packed bubble column. The third one is bubble column with static mixture, and the last one is multi-layered bubble column. Okay, the first type of bubble columns is cascade bubble column with sieve trays. Okay, the geometry of the trays within the column affect the extent and type of contact between the vapor and the liquid streams. Okay, sieve trays contain holes for vapor to flow through. There is another type of trays that have been used in industry, which is valve and bubble cap trays. Okay, valve trays have the same concept as sieve trays, as it contains holes with opening and closing valve. However, bubble cap trays contain caps that allow vapor to flow through tiny openings through the liquid. Here, the animation shows a tray-column reactor in action. Okay, the vapor stream flows up through the trays as shown by the movement of arrow from orange to yellow and contacts the down-flowing liquid stream shown by the movement of arrow from blue to violet, which causes the absorption of the red contaminant. Okay, this equipment is usually used in distillation columns. Okay, the next one is packed bubble column. Okay, the packed bubble columns contains a support plate, a liquid distributor, and a mist eliminator. Okay, the liquid stream flows through a liquid distributor and down the column due to gravity. Contaminants are transferred from the vapor to the liquid due to equilibrium or kinetic mechanisms, with the packing providing contact between phases for this transfer. As the animation shows, gases flow up through the packed bubble, shown by the arrows from orange to yellow, and the scrubbing liquid flow down the bed, shown by the arrow from blue to violet. Contaminants are transferred from the gas stream to the liquid stream. Okay, the packing provides a large surface area for gas to liquid mass transfer to occur. So the last type of bubble columns is multi-layered bubble columns. Okay, how the multi-layered bubble column is operating is by the solvent enters at the top and falls down the tube as a film. Gas enters at the bottom or top of the column to produce counter-current or co-current flow. The absorption of contaminants from the gas to the solvent depends on gas velocity, liquid gas distribution, and the tube surface condition. So, the animation shows the operation of multi-layered bubble columns. Multi-layered columns are also vertical shell and tube heat exchangers. As the animation demonstrates, the vapor rises through the tubes, shown by the movement of bubble from orange to yellow, and the solvent falls through the tubes, shown by the movement of arrow from blue to violet. I think that's all from me, and I hope you guys can gain some knowledge from this video. Thank you.